Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 5, lesson number 6, practice problems. Okay, first problem here. Match the graph to the following situations. You can use a graph multiple times. For each match, name possible independent and dependent variables and how you would label the axes. So A, Tyler pours the same amount of milk from a bottle every morning. So it's only happening once a day, which makes me think that goes with B. This much milk, he pours some out that morning, the amount stays the same all day. Next morning he pours out some more milk, it goes down. So A goes with B. And for each match, name possible independent and dependent. The independent would be time. Dependent would be milk left in the carton. Missing anything? How you would label the axes? Time, milk in the carton. A plant grows the same amount every week. So growing, so I'm going to go with A. This grows the same amount each week. Axes would be time measured in weeks and height of the plant probably. Grows the same amount every week, so it's growing at a constant rate, so it's linear. And time is independent, height of the plant is dependent. How tall it is depends on how long it's been growing. Okay, next. The day started very warm, but then it got colder. That's gonna be C, because temperature doesn't go down in jumps. Temperature starts out warm and then gets colder. Axes, time, probably in hours since midnight, maybe, what hour of the day it is. And temperature. A carnival has an entry fee of $5, and tickets for rides cost $1 each. So, starting at $5, I would guess we are graphing how many rides you went on and how much money you spent. Start at spending $5 for 0 rides to get in, and going up by $1 per ride. So D, I'm going to say, goes with A. Number of rides is independent. The amount of money you spent is dependent. Starts at 5 and goes up by $1 a day. What's next? Jada fills her aquarium with water. The graph shows the height of the water in centimeters in the aquarium as a function of time in minutes. So, time, how long we've been filling. Height of water in the aquarium. So, invent a story. At 0 minutes, start filling it with a hose. Or start filling, maybe not from a hose, maybe from the faucet. At 2 minutes, it's not going up anymore. It's staying the same. Turned off the water. The phone rang or something, so we turned off the water. At 3 minutes, we're filling again, And it looks like we're filling a little faster. Maybe we turned on the hot and cold faucet. Trying to get it to fill faster. Now, at 5 minutes, in, we turned off the water. And I feel like my handwriting's especially bad today. 5 minutes, we turned off the water, but it went down for a little bit. We turned off the water and drained some water because it was too full. And then at 7 minutes, stop, draining, and walk away. Because it's full the same amount, not going up, not going down. What is next? Recall the formula for area of a circle. Write an equation for relating a circle's radius r and area a. A equals pi r squared. Is area a function of the radius? So if we have a radius of 1, the area is 1 squared, which is 1 times pi. The area is pi. If the radius is 2, 2 squared is 4, the area would be 4 pi. Is area a function of the radius? Yes, it is. Is radius a function of the area? If we know the area of the circle, do we know what the radius is? Also, yes. We can't have 2 circles that have the same area and a different radius. Okay, fill in the missing parts of the table. If the radius is 3, if we plug in 3 squared is 9, the area would be 9 pi. If the area is 16 pi, if this is 16 pi, divide each side by, let me write this one out. If the area is 16 pi, and we know the area is equal to pi r squared, we could divide this side by pi, divide this side by pi. Those pi's cancel and those pi's canceled. We're left with 16 equals r squared. What do we square and get 16? 4. Now, 1/2. Area equals pi times the radius squared. 1/2 squared. Half of a half is a quarter. So, 1/4 times pi. Now, this one, the area is 100 pi. Do the same thing as before. We could cancel out pi on each side and know that 100 equals r squared. What do you square and get 100? 10. What have we got next? Okay, points with coordinates 4, 8, 2, 10, 5, 7 all lie on the line 2x plus 2y equals 24. Create a graph, plot the points, sketch the line. So, looking at these points, what do we want to use on our graph? Maybe you all love watching me fill in the scale, I'm sure. Now, coordinates 4, 8. 4, 8. That's one of the points on our line. 2, 10. 2, 10. And 5, 7. Graphed my line. Plot the point, sketch the line. Done. What's the slope of the line you graphed? Well, slope is rise over run. If I check a point here, we got a run of 1, rise of 1. Going down, the slope is -1 over 1, which is -1. What does this slope tell you about the relationship between lengths and widths of rectangles with a perimeter of 24? Well, this equation right here is x and y are all the lengths and widths of a rectangle with a perimeter of 24, because if we think about a rectangle, we have a length and another length and a width and another w. 2 L's plus 2 W's, and if the perimeter is 24, 2L plus 2W equals 24, 2X plus 2Y equals 24. So, this equation is the equation of all the possible rectangles with a perimeter of 24. What does the slope tell us about lengths and widths? Well, if the width goes up by 1, if our width goes up by 1, the length, can't even spell the word length right, goes down 1. If the width goes up 1, the length goes down 1. If we go to the right 1, we go down 1, which makes sense because if the perimeter is staying 24, if this gets 1 unit longer, this needs to get 1 unit shorter so that the perimeter stays the same. That was our last one for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.